Welcome back. In this video, we're going to try to find the limit as x goes to plus infinity of 1 plus sine x minus x. Here, if we try and compute this one term by term, this one, it will go to 1. This one will keep going up and down between minus 1 and 1. And this one will go to minus infinity. So basically, we have a sum of different limits, okay, and we can't conclude. Okay, so I think the best option to deal with this kind of limits is to think of this sign here. This sine of x, we know that the sine of x is always between minus 1 and 1. So as x gets bigger, this one will not exceed 1 or minus 1. Okay, so therefore we can think of sine of x as a negligible value, and we see that the limit of 1 minus x as x goes to plus infinity is minus infinity, and as x goes to plus infinity is minus infinity. We can even ignore this one because 1 is nothing. So basically we can ignore these two and think of this one as the limit of minus x. Okay, so here we see that it's plus infinity when x goes to minus infinity, and it's minus infinity as x goes to plus infinity. Okay, and it's not always possible to do it this way. So we found the limit by just hand waving. Okay, we can, but this is good idea to look at these problems. Okay, we can also see that we can treat this one graphically speaking. Okay, so we can ignore the 1 and sine and treat this function here, minus x, and we see that it goes to plus infinity as x goes to minus infinity, and it goes to minus infinity as x goes to plus infinity. Okay, but we are interested only in this one. We can treat the minus infinity by the end. Okay, one key idea to solve this kind of questions is to manipulate. Okay, try to get rid of these determined forms and using some values, maybe division or something like that. In our case, sorry, in our case we're gonna divide by x. Okay, why? Because we're gonna use this fact here, sine of x over x, as x goes to either plus infinity or minus infinity is 0. So we can use this one here. Okay, so here this limit we can write it as x times 1 over x plus sine of x over x minus 1. Okay, so here, and this becomes my limit. Okay, now I need to note some key ideas here. Let me just talk about this one here. Or in fact, let's do it here. So this limit, 1 over x plus sine of x over x minus 1, as x goes to plus infinity, this one is 0. This is 0 as we said earlier, but this one is minus 1. So this is minus 1 in fact. This limit between the bracket is minus 1. And x, when x goes to plus infinity, is plus infinity times this minus 1 will give us minus 1. So here, this is this proves that these limits we are using the properties of the product of the limits. This limit is minus 1, minus infinity. So this is minus infinity in fact. Okay, and one key idea that we can use from here too is that we can use the same thing here. Okay, when we are dealing with minus infinity. Here, when x goes to minus infinity, this one will go to 0, this one will go to 0, and this is minus 1. But here, the limit of this one, 1 over x plus sine of x over x minus 1 as x goes to minus infinity. So we said this one goes, as x goes to minus infinity, will go to minus 1. Okay, so the same thing here, minus 1, but the limit of x as x goes to minus infinity is minus infinity, and minus infinity times minus 1 is plus infinity. Okay, remember that minus 1 times minus infinity is plus infinity. It's not an undetermined form, no. And remember that minus infinity times plus infinity is minus infinity. Okay, we can define this one like this. We define them in this manner. Okay, and what can we get from here? What does it mean? What's the meaning of this? What's this limit? Okay, graphically, if we try to graph this function here, so we see that it's like we have the function 1 minus x. So this is the graph. But with the presence of the sine, okay, the sine is there, okay, it will make our function deviate or rotate or do some stuff around this function here. And therefore, this is just an explanation. It's not the exact one. If you want to see exactly the graph of the function, do it in the calculator. I'm just giving you an idea. Here, this one will go to minus infinity as x goes to plus infinity. And the same thing, this one will go to plus infinity as x goes to minus infinity. So our function will be giggling or maybe moving back and forth around or about the function y minus x. Okay. I think that's all we need here. There are other ways to solve this limit. Okay, this is one way. I hope to see you telling me what other ways can we use to solve this limit. Thank you very much. Please like, share, and subscribe.